Hello everyone, my name is Josh and welcome to today's video on simultaneous equations. Now, simultaneous equations is a question in maths where we get two equations, both linear in two unknowns that we've got. So what we want to do is solve these two equations to get a value of x and a value of y out of them. Now, the easiest way to do this is called the Gaussian elimination method, which sounds a lot more complicated than it is. So I'll take you through a question. Say that we've got two equations, 3x, let's make that a bit neater, 3x plus 2y equals 36, and another equation of 5x plus 4y equals 64. So what we want to do is label these equations 1 and 2. So the problem we have here is that we can't solve for one variable because the other one is in the way. So what we want to do is eliminate one of the variables, hence the name Gaussian elimination. So in order to do this, we need either x or y to be equal to each other in each equation. Now clearly this isn't the case here, so what we can do is take equation 1 and multiply it by 2. So that means that our new set of equations is 6x plus 4y equals 72, just timesing everything in equation 1 by 2, and 5x plus 4y equals 64. So now, in order to solve for x, we want to cancel out these y's, so we're going to subtract. We'll call this equation 3 and equation 2. So we do equation 3 minus 2 to do this next step. So subtracting these 4 y's cancel out, and we get 6x minus 5x. So 6x minus 5x equals 72 minus 64. And that gives us a value of x is equal to 8. So there's our first unknown solved. So in order to solve for the other unknown, the method is to quite simply substitute this value we've got back into one of the equations and then solve it for y. So in this case, we'll sub into equation 1. Sub into x equals 8. So in order to do this, we've now got 3 times 8 plus 2y is equal to 36. So we can solve this equation. 3/8 is 24. So 2y equals 36 minus 24, which is 12. And so y is equal to 6. And so that's it. That's all the Gaussian elimination method is. All you've got to do is cancel out one variable, solve for the remaining one, and then sub back in to get the one that you cancelled out in the first place. So the way you can check this method is by substituting in both of your variables to the other equation. So whichever equation you've used to get your second variable, substitute both back into the other equation in order to check it, because the point of these two equations is both are valid for whatever solution you get. So if you substitute both back in, we should get 64 here. So this wouldn't be necessary in an exam situation. It's just if you wanted to check that your answer was correct. So we sub x equals 8 and y equals 6 into equation 2. So this is 5 times 8 plus 64 times 6 should be equal to 64. So 4 sixes is 24. 5 eighths are 40. So we've got 40 plus 24 equals 64. And so 64 equals 64. Therefore, our solution is valid. And so that's all there is to it, really. I'll take you through a couple more examples just to help you fully understand this method, but it will just be the same thing again. So I'll do another one here. Okay, so this time we are going to solve the set of equations 8p minus 6q equals 56, and 6p plus 4q is equal to minus 9. So to solve this set of equations, we just follow the same method as we did before. We want to cancel out a variable. So in order to cancel out a variable, we look for the lowest factor that we can. So in this case, we can cancel out these q's if we make both of these in terms of 12q. So to do that, we need to do equation 1 times 2 and equation 2 times 3. So what we'll do is write these new equations out. So we get 16p minus 12q equals 112, and minus 2 times 3 we get 18p plus 12q equals minus 27. So these are our new equations. We'll call 3 and 4. It's useful just to label equations so that you can show all of your method clearly when you're doing an exam. So in order to cancel these out, this time we want to add the equations because we have a minus 12q here and a plus 12q here. So if we add equations 3 and 4 together, what we get now is 34p plus or minus 12q, which is 0, plus equals to 112 minus 27, and that is equal to 85. So this time we have 34p equals 85, which is not a very nice solution. So what we get is p equals 85 over 34. So p equals 85 over 34, and that is equal to 2.5. Your exam marker might prefer that you leave these in fractional form rather than decimal, but I find it's easier to show what's going on through decimals because a lot of people don't like fractions. I'm not a big fan of fractions, so this is just how I would do it, but in an exam situation, perhaps just simplify this fraction down and show it through that way. So now we do the same thing as before. We want to sub p equals 2.5 into equation 1. So to do that, we just put it in here. So 8 times 2.5 minus 6q equals 56. So 8 times 2.5 is 20. So 20 minus 6q equals 56. And then we solve this again. So we'll take that to be positive q, then subtract that. So 6q equals minus 36. Just taking the 6q to this side, subtracting the 56 from this side. So q is equal to minus 6. And those are our two solutions. Now we'll run the check again, just to make sure we've done it right, because I don't have solutions in front of me either, so it's a good idea that I check what I'm doing, so I'm not telling you wrong. So we'll substitute these back in. So 6 times 2.5, this is sub P and Q into equation 2. So that's 6 times 2.5 plus 4 times minus 6 equals minus 9. So that's 6 times 2.5, that is 15. 15 plus 4 times minus 6, that is minus 24. So 15 minus 24 equals minus 9, so that shows minus 9 is equal to minus 9. Therefore, our solutions are valid. Now, to my knowledge, for the level of examination that I'm teaching this about, which is GCSE level or American equivalent, you don't need to know any more than 2 equations that are both linear cancelling out like this. If you do actually need to know how to solve 3 equations or 4 equations or anything like that, then just let me know, but the methods are a lot more complicated, involving matrices, so I don't think you'll end up covering those. But again, if you have questions or that does seem to be the case, then just let me know. So I'll solve one more quick question in this video. So the final question I will go through in this video will be 3a minus 8b equals minus 5, and 5a minus 4b equals minus 13. So this is a nice, quick, easy one to solve. I mean, it might not be, like, if you're finding it more difficult than that, then just, again, talk to me and I'll try and help you understand it. Or if you have any particular question that you're struggling with, you can't get the solution to, just let me know. So in order to cancel this out, we want to get these 8b's cancelling. So in order to do that, we go 2 times equation 2. So our new equations are 3a minus 8b equals minus 5, and 5a, no, tell a lie, it's not that. It would be doubled, so 10a minus 8b equals minus 26. So these are our new equations. This is still equation 1, this is now equation 3. So what we want to do is subtract these 2 equations. So we get minus 8b minus minus 8b cancels out to 0. So that's equation 1 minus equation 3. So that would be minus 7a. Those cancel out. Is minus 5 minus minus 26. So that's minus 5 plus 26. That is equal to 21. So we can solve this nice and easy. A equals 21 over minus 7, which is minus 3. So now we want to go and sub A into equation 2. Nope, we want to sub it into equation 1. Just to stick with the convention that I've been going through. It doesn't really matter, but just in order for keeping everything the same as to not confuse anyone. Sub A into equation 1, so we get 3 times minus 3 minus 8b equals minus 5. So this is minus 9 minus 8b equals minus 5. So we want to rearrange this, so we get 8b on that side and then add 5 to this side, so 8b equals minus 4. So b equals minus 1/2. And there's our solution for b. So in order to check it, we will sub a and b into equation 2. So we'll do that. So it's 5 times minus 3 minus 4 times minus 0.5 equals minus 13. So we get minus 15 minus, and then in here we've got minus 2. So that'll be added, equals minus 13. So minus 13 equals minus 13. Therefore, our solution is valid. And that's all there is to it. So obviously all 3 examples, you can see the methods were pretty much the same. If you follow this Gaussian elimination method, it just works really well for any level of simultaneous equation they're likely to throw at you in an exam. It will likely be one in the same format that I've just put. Most likely it will be the same as the second one, where you have to multiply both equations by something just to make it a little bit more challenging. But if you can just work through these, there are hundreds of simultaneous equation questions online that if you use this method, you should be able to solve all of them, as long as there's only 2 equations. So I hope this has helped your understanding. If you have any particular questions or anything you're stuck on, then just let me know, either through comments or Reddit, or message me, however you choose. If there's any other topics that you want me to cover, just let me know via the same methods, and also let me know how you want me to go through them. So whether you want me to do an overview of the topic in theory, or go through exam questions, or just any worksheet questions, or anything like that, as to what would most benefit you. And most popular topics I will pick and make videos on when I can. I'll aim to cover as much material as people need, but obviously I have to balance it with my own studies as well. So thank you for watching this video. I hope it's helped, and I hope to see you next time.